about PEB in general and a little detail of what is PEB. Yes, go on, more. So steel all the way is increase in usage of steel buildings that is happening nowadays. PEB, according to me, is a boon to industrial construction because we can go for long spans, we can do it quicker, and I will come to that, I think, a little later. Then, so yes, this is the increase in usage of steel in buildings due to their ability to withstand harsh weather conditions, long-term durability, incredible insulation. The primary reasons why they are so popular is because such a construct can be erected in just a few days or so. I have a record of having done about 45,000 square feet in 45 days from pencil to production complete. Production means usage. Okay. The versatility of steel allows for the construction of complex architectural designs which would otherwise not be feasible or practical to accomplish. So that is what I call it as a design freedom. Then there are open areas, open structures that are also prone to be affected by elements such as humidity, heat, hazardous gases, call for durable steel structures. And wind and snow conditions creating a structure that can withstand elements requiring the yield and impact strengths offered by the use of steel beams. And the last one is the seismic activity. Yeah, go ahead. Next. Yeah, so the advantages that you will see is there is a tremendous reduction in the construction time, as I explained to you. I can give you another example where, a friend of mine has constructed a multi-storied building of 25 stories in Hyderabad, a huge one commercial building in 7 months. A builder would have taken about 4 years in RCC. So that is the kind of comparison as far as the time frame is concerned. Then it obviously reduces the lower cost because we talk about the bigger spans, we reduce number of columns, we reduce number of beams, we reduce number of footing, and so many and so go. Ease of expansion is also possible. In steel, it is very easily possible to go for expansions. There is assured quality that we can always assure right from the design itself, which is therefore also, I think, explained with the software, like Tekla and all other things, which guarantee and warranty you the kind of designing, detailing, and its performance. Energy efficient roof and wall systems and architectural versatility, as well as increased accountability, are some of the more additional elements or the advantages of this system. Next. So I'm just trying to compare the pre-engineered building versus the conventional buildings, where I say that the PEB buildings are 30%, minimum 30% lighter as compared to the conventional buildings as we go with the standard sections kind of stuff. So obviously the steel percentage of weight will also increase, and maybe sometimes the depth will also increase. So here we can go for a tapered depth and we can reduce the steels. Next one is structure weight. As I told you that we can replace this by what you call custom made sections, and they can be light gauge, lightweight, cold formed. So they will also automatically be lighter. The third one is design. Again, in terms of design, now of course he explained about the softwares, but basically it is very quick and efficient. We can run through our own AutoCAD initially, then probably Stat Pro, and then maybe we can go into the Tekla models also. So that is, design A. Then computerized analysis, which I told you through Tekla, and design C is the shop drawings, which he explained in details. And all these things can be checked again by the architects themselves, whether the required, results are possible. Now, vice versa, if you see in the conventional steel buildings, you will find the matter which I have mentioned here, that, unfortunately, the secondary members have to be selected from the standard members that are available in market. Conventional steel structure is designed with, of course, the frame kind of thing, with fewer design aids available. And substantial engineering and detailing is also required as far as the conventional steel buildings are concerned. Next. So we have consultants in-house design and drafting time is reduced here. Average 6 to 8 weeks we can deliver any kind of building according to me. It may require a little time. I can just spell out the time in detail that you will require about a month to close your GAD. You will require another month to probably do your the shop drawings, and you will require the rest of the probably a couple of months to raise your primary and secondary structure, and maybe the sheeting and all the ancillaries can be done in the remaining thing. So that's kind of thing which is on a very large scale. I'm just talking about that the whole thing can be done in 6 to 8 weeks, which is a span of 2 months itself. Whereas the same amount of volume of work can take about 26 weeks. Foundation, simple design, easy to construct and lightweight. And he also explained how these anchor bolts are very important factors which can be embedded through the plinth beams or even out of the plinth beams, independently of the columns, which will actually help you, speed up the matter. Erection is, of course, there is a tremendous amount of refined work as far as erection procedure and sequences are concerned, which are very complicated as far as conventional steel buildings are concerned. And then we have erection cost and time, where both cost and time erections are accurately known in the beginning, and here 20% more expensive than the original erection cost that you will have in the PEBs, obviously because the weight itself is going to be less. Then erection cost and time again, PEBs are erected by specialized PEB builders. Now, this is very important things that the right from the designing to probably taking the material to the site, the specialized PEB builders are required to manufacture as well as to erect. So I am coming to that next point, which is erection process, which is very easy. It is very, very formalized. And so once the training is given to the erection contractors, I think they can go ahead and do it. As compared to the conventional, where the erection is really very, very slow. Next. Now coming to these are some of the examples, award-winning projects that we have done. You can see a huge span. Probably it would have taken years and years as far as conventional things are concerned. And these are the internal detailing where we are taking care of the roof, underdeck insulation, the fire protection systems, as well as various kinds of piping systems. So this is project called Amber Enterprises, which we have done it in Supa MIDC, and we have obviously won the award also. This is a kind of an aesthetical and beautiful elevation that you get onto the gable wall. Next. A similar, project here in Bombay, near Bombay, Taloja, where we have done architecture as well as structural design and MEP design, things like that. It looks so beautiful. It's a Japanese building, and they were surprised that we have given them a 50-meter span building with underdeck insulation, and as simple and as beautiful as this. This is before, of course, handing over. Now it looks better than what a picture that lower picture is showing. And we also have the turbo ventilators and the skylights that pass through across. So there is a tremendous amount of light. You don't really require any windows, but we have work level windows which are continuous, and that is the specialty of ours. We don't go for one window in one bay. We go for continuous windows, so it gives continuous light at the work level. Next. Codes and advantages also very important. PEB building design as per IS 800 are 15% cheaper over conventional structure. They are shop fabricated, controlled quality as compared to conventional site arc welding. 30 to 40% saving in time, or even more, as I have proved. And then since PEB provide for larger base spacing, there will be less number of footings compared to conventional, resulting in reduced civil costs. Because it will not only reduce footing, it will reduce columns, it will reduce beams. So there's overall going to be a great impact. Next. PEB design shall be as per IS code is our normal condition, and the frame members are to be designed according with IS 800 2007, and of course these are getting updated almost every year. Double side welding to be considered for primaries. Connections and base plates are designed as per actual moments and forces, and of course they can be verified on the softwares. Frame design analysis to be done, basic to be done. We still insist that they should be done on a StatPro and then maybe pushed on to the other softwares for verifications. Nut bolt should be coated and 10.4 HT. All sheeting screw should have cap of sheeting color. All primary members should be sandblasted, and all downtakes should be metal and from outside of the building. Now, although they have said outside, we have detailing where the downtakes are from inside, so that we have very beautiful elevation from outside. So we could, modify these things. Next. Live load on the mezzanines. Wherever the mezzanines are there, the live load factor is also very important. In fact, we have done some buildings where the live load have gone up to 700, 7 tons, metric tons, also per square meter. It is possible to do that. So we have, I think, I don't know whether I've shown or maybe it is there down the line, where we have got mezzanines, 4 mezzanines in a building within where the loading is 2 tons to 3 tons per square meter. Safety net should be provided below the skylight panel so that the safety factors are also considered. Load of the sprinkler to be considered on roof purlin, as well as nowadays we also consider the load for the solar panels at the top, which may come at the same time or maybe later. Bracing will not be allowed on locations of the door, so there we give a kind of portal design frame and width of the column. Of course, normally we advise it has to be 750 or 7.5 meters. Uh, you know, normally, and the columns would be, normally we of course stop it at the plinth level and then go up to 3 meters with the windows and the walls. And further above will be, of course, the PEB with the sheeting. Load of services to be considered on each columns must also be specified for designers. Next. Yeah, so design data for PV is column out to out along with width of the building, column center to center. This is from architectural and working drawing perspective. I'm explaining. Mentioned tile level, column center to center spacing at every grid. The roof slope, we have two types of roofings now. We generally had the screw down type roofing. Now we are going for what is known as a standing SIP where it is jointless. Then the slope is reduced to 3 degrees. Earlier slope was of course 6 degrees. So we almost have a very flat kind of roof now. So location of wind bracing is very important from, I think Musefa showed his very beautiful roof drawing with the wind bracings. Type of bracing on roof and wall, roof panel sheet and insulation and its density. So we normally provide and either you go for a sandwich panel roof on the top, where everything is taken care of as far as insulation is concerned, or we have a regular roof on the top, which is of course the roof, and then we have about underdeck insulation. Normally we go for a glass wool insulation by Saint-Gobain or UP and which is 24 kg density. Wall panel and its distance from column face is also very important, and this is critical in my case because we have a wall panel which is 500 out of the what we call steel line. So that is where I can have a wall also which is independent of the columns, and then we have a window which can run through. This is actually the detail which is done by PDA itself, and hardly you see this kind of detail in other buildings. Side wall girds and end wall girds with projections from columns. Next day, we. In brief, that is the sequence of going about a PEB. We have the comparing to be done, as far as the steel content is concerned. Supposing you have 4 companies which are quoting for a similar kind of architectural design, then of course we will compare the total steel content. My experience is, if you have the branded companies, their steel content will be less, but cost per square meter of processing will be higher, but steel content will be less because they will be, doing precise designing and detailing. Whereas the ordinary companies will probably not do the same, and so their steel content will be higher. Then you compare the erection cost also from agency to agency. Ask the agency to study the project, design in terms of plans, elevations, and section very carefully. Select agencies which shall give force acting on columns. Subsequently, because they are required to design my foundation columns and footings. Okay, so that the AB plan can also be prepared by jointly by both. They have to match each other very properly. This is a very important stage where the anchor bolt plan is matched with the column spacings. Agency to submit sets of drawings known as GAD, which I think was also explained, to verify and certified by the architect. And then of course the anchor bolts will be dispatched at site with the templates for casting of the anchor bolts going into the stub columns. Next. Manufacturing accordingly the primary and secondary section. architect to visit the manufacturing unit before this. Now, this is a very important stage as far as we are concerned, because we always would love to visit the manufacturing plant and check, all the things that is manufactured as well as the sequence of delivery. That will help me, saving time on erection. So supply of ancillary is first done. Then we go into the team to move on site to execute preliminary work, maybe straightening, maybe painting, maybe whatever they want to do initially. Erection teams to execute the primary and secondary work, then finalize the alignment of the structure, again very important stage, and complete the installment of the secondary structure. Then comes the installation of the roofing sheets and cladding as per design. And then, of course, as Muzeba explained, installing the corners, soffit panels, doors, window frames, turbo ventilators, polycarbonate glazing panels, and of course, the underdeck roof insulation, because the underdeck roof insulation has to be installed before the sheeting. And then finally, the finishing touches and handing over. So these are the 16 stages in which the work is completed, and it is absolutely flawless as experienced by us in many years. Next. So this is a building I was talking about, a multi-storied building, looks like a RCC building, but totally it is in steel, it is in Mumbai, and all the bands that you see are the mezzanines, which are taking a load of about 2 tons to 3 tons per square meter. So that is the square meter area. We also have a very nice rooftop terrace and an office area on the top where the customers can be entertained. And we have a factory shade adjoining. So all these 3-4 floors that we are talking about can overlook onto the production. Next. This is just a thought process of the plan that I explained to you next. Actually, yeah, this is the section, you can see the section where we have a gantry at the top, which is 20 tons. I told you about the main mezzanine floor, which is designed for 7 metric tons per, loading. And then these are the other, mezzanines which overlook the production, except the top floor, which is office. Next. So friends, it's time to welcome this new technology, probably refine them to suit our designs as cost parameters, working conditions, but then we all will probably succeed in catching up with the world in construction and yet achieve our own Indian flavor. Then and then only we will be worthy to say that we belong to the strongest economy in the world. So it is steel alone which will make it happen. This is the message I wanted to give to all the listeners of this wonderful program. And thank you, Ace Magazine, for inviting me on this platform.